My name is Kiruthika Gopal. I'm the product manager for Apex Block Storage at Dell Technologies. And I'm really excited to be sharing about some of the amazing things that we have been building over years with respect to Apex Block Storage and the whole universal storage layer concept. So in the last session, you may have heard Pratish talk about the universal storage layer and how we are bringing some of the industry leading Dell storage to the public cloud, right? Which is essentially the ground to cloud. And as part of that, the very first product we brought to market is Dell Apex Block Storage. Dell Apex Block Storage is based on PowerFlex IP that some of you may have heard about, right? So it's essentially a software-defined storage from Dell that's been around for over a decade. And customers love it for the performance it offers, the scalability, and the extreme flexibility. Right now, we want to bring all these features to the public cloud and extend the same benefits for the customers deploying in the public cloud as well. With Apex Block Storage, before we get into what's good about it, the features and things like that, it is available for both AWS and Azure, and it's available in the marketplaces, the respective marketplaces. If our customers are looking to draw down on the cloud commit, they can actually go to the marketplaces and purchase the software. Alternatively, if they choose to purchase it directly from Dell, that is available as well. With Apex Block Storage, one of the main goal is to help customers lower the overall TCO, right? And along with that, we also wanted to help them bring some of the applications that are currently, that otherwise they cannot take it to the public cloud because of performance SLAs and things like that, right? So specifically mission critical applications which demand high IOPS and that are latency sensitive, we are able to help them take those kind of applications to the public cloud. And thirdly, we also heard about the seamless data mobility across hyperscalers and also between on-prem and cloud. That is possible as well using native set of tools. And with Apex Block Storage, I definitely want to call out a very unique functionality that's called multi-AZ durability. And with this, we are able to increase the overall resiliency of the storage cluster. And we'll talk about it in the next few minutes. And finally, with Apex Block Storage, we are actually able to help the customers consolidate a wide variety of workloads. It could be databases, it could be analytics, it could be clinical applications, right? So any type of workloads, we are essentially helping them consolidate and put it in the single storage cluster, if you may.
There's a number that jumps out at me there.
Is it 100?
100x better performance, but I see the little 3, which means there's some more information there. Can you explain what you're referring to when you say 100x better performance?
Absolutely, absolutely. That's a great question. And one of the things that we really boast about Apex Block Storage is the performance, right? As I said, and we have a lot of performance data to share with you, and that'll kind of explain on what this 100x means. So essentially, we are with Apex Block Storage, and I don't want to get into too much of the details since we have a lot of that information being covered.
Okay.
Essentially, it is scalable, highly scalable to hundreds of nodes, right? And with that, we are able to achieve millions of IOPS that is not possible in the public cloud at this time. And when we did a comparison, based on the internal testing, we were able to see that a single volume within a single cluster was able to deliver 100 times or more than the existing public cloud storage.
Okay.
And then I'll share the data points in just a few minutes.
Okay, excellent. Thank you.
I'm actually curious about the pre-committed cloud spend, leveraging that.
Sure. So that essentially means that, since we are available in the Amazon and the Azure marketplace, you can, if customers have a pre-committed cloud spend and they want to draw down on the cloud spend, we actually let them purchase not only the hyperscaler infrastructure, but also the software, the Dell software, which is Apex Block Storage, with the hyperscaler and draw down on the spend.
So it goes towards their EDP.
Exactly. So in terms of Apex Block Storage, one of the things that I want to call out is we are not competing with the public cloud, right? So we are essentially working with the hyperscalers, and we want to elevate the customer's experience in their cloud journey, right? So we are deploying our software in the public cloud infrastructure, and we want to help our customers for unique scenarios which are currently otherwise not addressed in the public cloud, right? So one of the things that I called out, and I keep repeating myself on the performance and scalability, and I'll continue to do so in the rest of my session. we are able to deliver extreme performance. We are not really like, talking about like, few hundred thousands, but we are talking in millions. So we are able to deliver this extreme performance on-prem, and we are extending the same thing in the public cloud as well, right? So if customers are looking to deploy their mission-critical applications that demand extreme IOPS and sub-millisecond latency, we are able to achieve that in the public cloud as well. And improving resiliency. So customers are used to a certain kind of resiliency on-prem, right? 6 nines has been a norm for decades, and we are able to achieve the same thing in the public cloud using very cheaper storage. That's the best part of it. Using our native data protection and other functionalities, we are able to extend the same level of resiliency even in the public cloud. Predictable costs. This is one of the concerns that we often hear, right? So we don't charge for the IOPS. We are able to utilize the instances and deliver all the IOPS that it has to offer. We don't charge for the IOPS. And thus, customers can expect predictable costs when they are deploying their cluster in the cloud. Seamless data mobility. Again, we have similar set of management tools, APIs, and automation tools. So you have native functionalities as well, which you can use to move your data irrespective of where the data is. It could be on-prem, it could be in the cloud or in the edge. And finally, consistent tools. Like I said, the same management interface you are used to on-prem, you can use it in the cloud as well. One of the things that we hear very often from the customers is they have the data on-prem and they are looking to move to a couple of hyperscalers, right? So that is the whole multi-cloud that was being discussed before. And when they are placing the data across multiple hyperscalers, one of the things they are missing out is now they have to go and build a separate set of APIs and tools for those specific hyperscalers. And with Apex Block Storage, we are giving the consistent experience to our customers, irrespective of where the data is.
I have a quick question while that switches over.
Sure.
I was wondering, since for anyone out there that may be wondering online, I see that we see AWS and Azure, and I was wondering, what about Google?
Absolutely. That's a great question. We launched Apex Block Storage for AWS in calendar year 22. Last year in October, we added support for Azure. So GCP is definitely in our roadmap, and we are looking to address that in future.
Cool.
Thank you.
So if I can go back, and there's variations of VBS, right?
Absolutely.
You've got all the way down to disk. What is that number coming from, and what are you comparing to what?
I will definitely share more details in the next few slides, but to answer your question, we picked the best-in-class EBS, which is IO2 Block Express.
Okay.
Yeah.
Okay. Then the other thing is that you stated that you were using the same SDS that you have on-prem in the cloud.
Yeah.
For clarification, is that pure PowerScale SDS, or is Apex Block that's on-prem different than PowerScale SDS?
That's a great question, and I'm really glad you brought it up. So it is PowerFlex. PowerScale is the file, the Dell file storage. So this is PowerFlex. Yep.
I do that all the time with those two. Okay, it's PowerFlex, which is Scale IO, which is why it confuses
Exactly.
me completely. You guys should never have done that branding. I cannot do. I know I'm thinking Scale IO when I'm saying it, but okay. So
you're right. So it's Scale IO.
That is Scale IO. That is your Apex Block Storage on-prem. Is that the same code on-prem with Apex Block in the cloud? And is it that the same code lines for PowerFlex?
Exactly. And that's a great question. And thank you so much for asking that. The Apex Block Storage that we deploy in the public cloud is exactly the same code that we have on-prem.
Okay.
And the best part is PowerFlex, as you may have heard of, and Scale IO, right? By design, it's a software-defined storage.
Yeah.
It can be deployed on any x86 server, right? We use that principle. We just treated the hyperscaler infrastructure as yet another x86 environment, and we deployed it. We didn't have to re-architect the code at all to be deployed in the public cloud, right?
Did you have to do anything with AWS or Azure in terms of the architecture of the hardware that you're based on? Because I know you had to do that with Isilon.
We didn't have to, honestly, we didn't have to do anything. I mean, we could pick the PowerFlex software.
You just dropped it on what?
So we actually have validated with two types of instances. Technically, I can deploy it anywhere, right, on any instance, but we pick the i3 instances, and then I'll get to that.
Okay.
Probably it'll make more sense like when I'm explaining how it is deployed. We pick two instances, C5n instances and the i3n instances. So I'll explain what the difference is between the two, but we picked these two instance types because we want to deliver the best performance, right? So we kind of like did an analysis on what delivers the best performance for the dollar, and I identified these two instances. But technically, we can go ahead and deploy the software on any type of instance.
Yeah, I could keep digging, but the next one would be, can I replicate between AWS and Azure?
Technically, you can, right? So we just have to work on the legalities of moving the data across the hyperscalers.
Egress fees.
Yeah, but our software features allows you to replicate from on-prem to the cloud, across regions within the cloud. So anything is possible. We have tested that; it works, but we have to work on the legality of that.
Okay, thank you.
So from that perspective, you're talking about legalities and more like business process to overcome. I remember like years ago when this was still Scale.io, maybe even before it was acquired, some SE somewhere basically put it in AWS, test it out and see what it could do, and achieved many of the claims that you're talking about now. That was years ago. What, like, from a timing perspective, why is it taking this long to productize it?
Essentially, like, I mean, that's a great question, right? In fact, I will tell you that, we have done some of the tests even before we productized it, because it's easier to, like, stand up a cluster as opposed to identifying the hardware, right? So we have done that. Why did it take this long? Essentially, like, as a team, like, as a organization, we had to, like, work on our strategy on specifically, like, what is that product we are taking to the cloud, right? Like, as you are aware, we have many amazing products within the Dell portfolio, right? And essentially, as part of the universal storage layer, we want to make sure that we are taking the best IP to the public cloud that will solve for various needs, right? And that took time, and essentially the whole productization, right? Working with hyperscalers, identifying the instance types or even the virtual machines, and building all the productization, being able to like transact with the hyperscalers and with the customers. So those are some of the productization aspect of it that essentially took us a little longer. So moving on to the overview, right? So I talked about Apex block storage. I think I covered some of the aspects of how we deploy it in the hyper scalar infrastructure, based on the Q&A we had. But we actually take the Apex block storage software and deploy it on AWS EC2 instances. And we have two flavors of deployment that we offer to the customers, right? One of it is deploying the software on EC2 instances and consuming the EBS volumes, essentially attaching EBS volumes, GP3 in this case, and aggregating multiple EC2 instances in order to create the Apex block storage cluster, right? So that is called the balanced option. It offers a balanced performance, right? The advantage of that is EBS volume, as you are aware, it's a persistent storage, right? The second option we have is performance optimized, and that utilizes what Amazon calls as EC2 instant stores, right? And that comes with locally attached NVMe SSDs. They're extreme, they can deliver extreme performance. We essentially aggregate a bunch of those EC2 instant stores. We can start with a minimum of 3, and the best part with Apex block storage is it can go up to 512 storage nodes, right? And we are able to aggregate a bunch of them and create a cluster. The only caveat there is the EC2, the NVMe SSDs are ephemeral in nature. So if you have a transient workload, if you have to constantly shut down your cluster and things like that, then you have to back up your data, right? So that's kind of the caveat there. Same thing with the Microsoft Azure architecture as well. So we deploy the software on virtual machines and attach the premium SSD V2s for the persistent configuration or the balanced configuration. Likewise, we have a performance optimized in the Azure infrastructure as well, wherein we utilize the virtual machines that comes with locally attached NVMe SSDs. I think the L32s and the L64s that comes with the NVMe SSDs, and we create a Apex block storage cluster based on that, right? And with this, we have also validated Dell Data Domain Virtual Edition. So if you are creating or taking any Apex block storage snapshots, you can actually back it up to a cheaper media such as S3 using DTVE. Now let's look at some of the key use cases on why or how customers are using this, right? With Apex block storage, the most common use cases is database workloads, right, which demands that sub-millisecond latency. Workloads like such as SQL, Oracle, and so on. So those are some of the applications that benefit from the performance that Apex block storage delivers, right? Analytics applications. So, if you want to run analytics workloads, that's another great use case. We have customers who have their production on-prem and want to do the test and dev in the public cloud. That's another great use case as well. So we have customers using running clinical applications that demands the sub-millisecond latency. And they utilize the Apex block storage performance.
So I have a question around this sort of sub-millisecond latency and the way you're achieving that, because it sounds like you're essentially building a storage array.
Right.
In the cloud, and then other EC2 instances or Azure VMs are consuming that storage array. So what type of connectivity am I expected to have between the Azure VMs consuming the storage and this storage array you've built to get that sub-millisecond latency? Because I'm thinking, wouldn't I just attach a local NVMe drive to those Azure VMs to get even faster storage? How is it faster across the network than something that's attached to the VM locally?
Right. So, by design, PowerFlex has a mesh mirror architecture, right? So, and then we have the storage nodes are essentially what we call as SDS. We aggregate a bunch of these storage nodes, which we call storage data server, and then we have it's a proprietary host. It's not the standard like iSCSI or the fiber channel host, but we have what we call as storage data clients, SDCs, that gets deployed essentially, in the compute instances that you're bringing where the applications resides.
Okay.
And, essentially those SDCs consume the volumes that you create on your SDS nodes.
Okay, so you're not provisioning this using the cloud tools to attach volumes. You're using this SDC software that has to be deployed on each VM to connect in and consume it. And do you have recommendations around placement of those virtual machines in regards to the cluster? Should they go in the same availability zone or zone if you're in Azure because they call it something different? Should they be in a placement group? Is there advice around that to get maximum performance?
So to be very honest, we don't have any specific requirement around having it in the same placement zone. But technically, if you are sticking with the same region, then it's more advisable. We do pretty well with the multi-AZ placement, but as long as it is not in a different region, I think we'll avoid the latencies.
And this is all happening across the network.
Right.
So I have to, in my mind, think about the egress charges between availability zones.
You're right, but to be very honest, I think it's very small, right? It's like 1 cent a gig, the data transfer cost. But yeah, I mean, if we are, again, I'll get into the details. So, perhaps that's a great segue for me to explain about the different deployment options, which will also be covered. But, you have a choice to put the entire storage cluster within a single availability zone, or you can actually stretch that cluster across multiple availability zones. I'll explain how we do that in the next few slides. So you have an option. If you are comfortable with the single availability zone resiliency, great, you can put everything within that. But if you want that multi-availability zone resiliency, then we stretch it. And then, to answer your question, yes, we do have that 1 cent or whatever that charge is across the AZs. But, you also have to think about the capacity charges that we are saving on. Like, we are not requiring additional capacity when we are deploying ourselves on a multi-AZ. I'll get to that in a minute. Probably that'll explain it. But we have a lot more advantages in deploying a multi-AZ configuration as opposed to a single AZ.
I'm just thinking through the cost implications for myself. If I was comparing apples to apples in terms of performance, what does it look like from a cost perspective? And I can't forget about that network egress charge if I'm doing a multi-AZ deployment.
You're right. Yeah.
Can I have a question about this client software that you install on the computer? it's basically piece of the software on the driver's level, or it's a daemon? How is the form of this client software that
So
it's access to
it's
the
an
storage?
it's a package that gets installed in the EC2 instances, right? In case of Amazon, and it's wherever you have your application resides, and you essentially think of it as a host that you're mapping to a block volume.
Sure, and because of this piece of software is working on the instance, it will consume some of the resources of the instance.
It's very minimal though. It's very, very minimal. I mean, I can share like, papers that explain how, but like it's very minimal.
Another question there, do you need a local buffer?
No caching required.
No caching required on the instance.
Right.
So
Nothing.
basically, it's just a piece of software that connect you to the Scale.io platform.
Storage nodes. Exactly.
Okay, thank you.
And just on that note, then, does that mean that my clients can only be EC2 instances or virtual machines, or can I connect other cloud native solutions to the storage if I wanted to leverage the Apex storage system for other cloud?
Are you essentially talking about, do we have integration with the other cloud services? I mean, I think technically you should be able to, to be very honest, we haven't validated a lot because we've not heard of asks. But yeah, I mean, if there is a customer requirement, then definitely we'll go ahead and we're not integrated per se, but if any of the services are, can work with that, then we can certainly validate that. Like a cloud watch or something like that.
A lot of those services don't consume block storage, right? They're expecting object storage.
But this serves up.
This is serving a block storage.
Yeah, okay. Only block.
I think I saw on an earlier slide that there's also an object
that's
storage solution,
I thought
but
I saw
this is
file.
pure block.
Right. So yeah, perhaps I should clarify those. So as part of our universal storage layer, story, our aim is to take Dell's block, file, object, and the protection, software solutions to the public cloud, right? And in this specific session that I'm talking about, we are specifically focusing on the blocks.
Got it. Okay, sorry. Yeah. Cool.
So the question on your availability number, what's required for that availability of 6 nines? Is that assuming a replication to another AZ, or what kind of setup are you looking at?
We are not requiring any replication. That's not factored in. So essentially, our product is designed to deliver, whether it's on-prem, right, or in the cloud, it is designed to deliver 6 nines. And we have actually, if they are using what we validated, which is the i3EN instances or the C5N instances with EBS volumes attached, through our data protection strategy, we are able to meet with the 6 nines.
And is that in your SLA that you're delivering in the contract?
To be very honest, I don't know if any of the storage vendor guarantees, right? So because when we talk about the availability, it depends on so many other factors.
Well, they do have. That's why I'm asking, what are the factors that you're guaranteeing on, and what is the how you're guaranteeing that? Because normally, if you were on-prem and you own the box,
exactly,
you got the box, but you don't own. You don't own the AZ and that kind of stuff. So where's the liability limitation, et cetera?
Right. It depends on various factors. And right, I mean, from the storage node perspective, based on what we see,
it's the code.
Guarantee. But there are so many other factors that form the entire infrastructure, and so.
But so the funny part of that, though, then comparison, if your availability number is really based on your code availability, right? Your code,
right?
SDS. And you're not measuring yourself down to the hardware because you don't own the hardware.
Right.
They're measuring themselves down to the hardware. So that's not an apples to apples availability number.
You have a valid point.
Okay. Yeah. Okay. So that's and then we just went down again.
I mean, just to pile on to Camberley's point, typical SLA for a public cloud is 3 nines availability. If you go to AWS, that's what they'll give you.
Right.
There's that's the network, that's the data.
Exactly. That's right.
I mean, your one small part of it might be 6 nines, but that doesn't translate to service availability.
That is true. We are really talking about the storage.
Maybe clarifying what you mean so you don't
Right, right. I mean, I think his point is like, very valid, which is like, we are strictly talking about the storage part of it,
Yeah.
not factoring in the networking and the other
Yeah,
aspects.
and I think it's it's an understandable situation when we get up to the cloud. When we start stacking stuff up on the cloud, there's so many variables in that piece of it. It's
Absolutely. Yep.
it's one of the wonderful things about it.
Yep. So moving on to the key value and differentiation, right? So when we talk about Apex block storage, it is not yet another storage in the public cloud. We specifically want to call out the key differentiation that the product offers. The number one being the extreme performance. So if you look at the table below, right? So we can actually deliver millions of IOPS for a single volume. And I'll share the numbers in just a minute. The next thing is flexibility and scalability. So again, I have more data points on how our scalability looks like. So we can start off with the storage node that is a minimum of 3 or 5 based on the configuration. We can scale up to 512 storage nodes. And likewise, compute instances, right? So we talked about deploying our SDCs on the compute instances. You can start with 1 attached to a cluster, or you can scale up to 2048. Right? So that's an unimaginable number. And the best part is you can actually independently scale compute and storage with Apex block storage. Multi-AZ durability, again, that's something very, very unique. We have, and we'll get to that in a minute. Essentially, we give the customer an option to deploy their entire storage cluster within a single availability zone or a multi-availability zone, right? So when we are deploying the storage cluster on a multi-AZ, we are not really requiring additional capacity. It's the exact same capacity that we are deploying in the single AZ. We are essentially separating out the storage nodes and spreading it across 3 different AZs or more, right? And finally, hybrid cloud mobility. So using native tools, you can actually move the data seamlessly between on-prem and the cloud across regions. And someone even asked a question about, hey, can I move from one hyperscaler to another, right? And the table below kind of gives you a snapshot view of what we are offering, right? And again, this is essentially to showcase that, hey, this is what the public cloud offers, the native public cloud offering offers. If that fits your application needs, great, right? If you need more than that, that is where we come in and we solve for that use case. A single volume, Apex block storage volume, can scale up to 1 petabyte, right? And multi-AZ, that's something we offer. No, no penalty on additional capacity requirement or replication requirement and things like that. Thin provisioning. This has been available in the on-prem world it's been table stakes in the on-prem world for almost decades, right? But what you find out is this is not available with any of the native public cloud storage. Sorry, I'm just going to take a minute so the screen comes back up. And snapshots and clones. What you find out when you're provisioning in the public cloud is you pay for snapshots, right? And the snapshots get stored in a cheaper medium, right? With Apex block, the snapshots get stored on the same hot tier, and we don't charge any additional fee. It's a Apex block storage snapshot. And finally, replication. We have asynchronous replication that you can use. We also have a feature called Snap Mobility that will be discussed later on in the session. So that can be used as well, and kind of gives a comparison of what you get with the native public cloud storage and what we have to offer. And customers are it gives customers the flexibility to choose what they want based on their application needs, and also to future proof. So I kept talking about multi-AZ a lot, right? So, and this is something very, very unique to the product. And again, this is not something we architected for the cloud. It's something that we have had in the on-prem world for over a decade. And the way it's called a fault set feature on-prem, and it essentially protects the data from an entire rack failing out or losing power. We extended the same thing to the public cloud, right? And now we are treating each of the availability zone as a rack. So in this example, you'll see that we are constructing a storage cluster using 9 instances or virtual machines. If customer chooses a single AZ deployment, we'll place all the 9 instances with storage attached within a single availability zone, right? That's an option customer can pick. If they choose a multi-AZ deployment, we are essentially still using the same 9 instances of virtual machines, but we are just placing 3 in each of the availability zones.
Is 9 the minimum?
No, the 3 is the minimum. So I can keep
Okay.
1 each. So this example just happens to have 9.
Okay.
So I can have 3 and I can place, one storage node in each of the AZ.
Okay. And is there just pre-configured sizes and disk layouts for the nodes, or is there some amount of variability and ability to customize what disks are attached to the instances?
Sure, that's a great question. So technically, again, like I said, I can configure any disk drive, right? The only requirement is it all has to be uniform for performance reasons.
Okay.
But, for ease of use and things like that, what we are requiring, and again, it will be showcased in the next few sessions, is we are asking customers to input what their capacity and IOPS requirements are. And based on that, we have, we essentially aggregate. It's 2 components, capacity and IOPS. Based on that, we aggregate certain number of instances with certain drive sizes.
2 more questions.
Sure.
What is the upgrade process? So I'm running a 9-node cluster, and a new instance size is released by AWS that will improve my performance. Can I introduce that new size into my cluster, or do I have to build a new cluster, replicate everything over, and then shut down the old cluster?
Yeah, it's a second. It's a second. Typically and it's a general practice even that's been on-prem, and that's been, that's existence on-prem, right? We don't like mixing different instance types. So if a new instance type with better performance is introduced, we would essentially validate that and offer. And like you said, we'll have to migrate the data. We have a volume migration functionality as well. So, but that works across the storage pools, right? So I can, I essentially have to, replicate or migrate the data and then destroy the.
I was thinking every year they introduce new instance families with different performance characteristics, and the next reInvent, I'm gonna be like, oh, well, I want to use that instance size now. That's
Right.
even better. So I was curious what the migration process or the upgrade process would be for that.
Absolutely. And we are working very, very closely with the hyperscalers, right? So we get to know ahead of time. They share the roadmaps on if new instances with better performances being introduced. They know very well on what we are using, and if it is going to be helpful to us, they do share that information. We work very closely with the hyperscalers and use the best, instant types that they are delivering. But yeah, the upgrade process is in your use case, we'll have to migrate it and then close the cluster. Yeah.
I don't understand this slide at all. You said you deploy in the single AZ, you've got 9 instances.
Right.
And now you've got arrows everywhere. So help me understand what these arrows mean. Because I like the blue arrow in the middle.
Arrows look like
pointing to
they're
the
off
title.
by a little bit.
Yeah, are they just off? Like, I don't understand what this slide is trying to communicate. Can you help me understand this?
Absolutely, and I apologize for that. So on the left side, you see a single AZ configuration, right? So we have 9 instances that make up the cluster. The arrows that are talking to each instance just means it's a mesh network.
Okay.
So they are fully connected, right? That forms a cluster. And all these 9 instances are placed in a single availability zone, right?
Just to stop you, I'm now exactly where he is. So the 3 on the furthest left aren't connected to anything then?
Yeah, it's I think
They're
it's
just shifted to the right. The arrows are just
it's a slide error.
So you haven't got 3 just sitting there on their own, minding their own business.
They're just chilling.
Yeah, just chilling. The arrows are in
So
the
there's
wrong
9.
place.
It's there to mess up the speaker totally.
Yeah, there's 9 on the left, all in the single AZ, or we could have 3 in 3 different
Availability zones.
fault domains.
Fault domains or availability zones. Yeah. So this is AZ1, AZ2, AZ3.
Yeah, I also had to tilt my head to see that. So, okay. Choice for, okay. I think I understand it now.
Can you spread it across the regions?
You can technically do that, and we've even tried it. You will have latency issues, so it's not something we would recommend.
Probably don't.
So it's impact performance if you try to do that. So,
But you said that replication can happen, right? So you can have different clusters of the Apex block storage
Absolutely.
in one region and another Apex block storage cluster in the second region and do the replication.
Absolutely. You're already reading my mind. So the next slides,
Okay.
in the next couple of slides, you have that. So
So-
you could do that.
So the minimum you said is 9.
The minimum is 3 or 5. So if it's a performance optimized configuration that's based on I3EN instances, the minimum number of instances required to form the cluster is 3.
Mhm.
If it is the balanced configuration that uses the C5N instances with EBS volumes attached, the minimum will be 5.
How are you dealing, because it's 3 and 5, so I assume that you're using a voting protocol somewhere to designate the master in the cluster, master node.
It's not really a master slave kind of thing here. It's a mirror RAID at this time, and we are making improvements in the future, right? Like in the next releases, we just have a copy of the data in one of the
Okay.
other layout.
But because my question was like, if you have 3 availability zones and let's say that the data is spread across them, right? So in each availability zone, we have some copies of some data.
Right.
And we have networking issue. Let's say that we have not even a networking issue, but EM issue, which is happening at time to time, right? So suddenly all of those connections doesn't have access to each other. How you manage to deal with the split brain problem? Because it can occur, especially when you do it in 3 different completely setups like availability zones.
Right. So,
You have
we have 3 AZs, but we store a second copy, right? So we have the data and then the copy of it is stored in one of the AZs. So the second block may be in AZ2 and the copy of it will be in AZ3, right? So it gets immediately mirrored.
But the thing is, when the network doesn't work, we talk about very complicated stack, cloud stack, and the network can, from different reasons, not work between availability zones. Each of the sites starts to be independent, and if the applications are writing to those sites, how you manage exactly the problem of the split brain?
Split brain. Yeah, I mean, honestly, I haven't come across anything like that.
Mhm.
Something for us to go back and investigate. We have a solid team that's tested various scenarios, and we haven't run into this kind of issue. But yeah, definitely something for us to go back and see.
Thank you very much.
Thank you.
I have one last question on this slide.
Sure.
Because earlier you said multi-AZ without copies of the data.
Right. So what I meant was
I
we're not.
I wanted to know on the right, aren't you just spreading isn't this a copy of the data across AZ?
Right, but that's our data protection though. It's a mirrored RAID. So we have 2 copies. We place one copy on one AZ and another copy on another AZ. What we are not doing is taking a volume, right? I mean, that's what currently people have to do, right? Which is, okay, I create a volume on one AZ. I want multi-AZ resilience. I replicate this volume to another availability zone, right? So you're doubling up the capacity. So in our case, it's whether it's single AZ or multi-AZ, the way we protect the data is mirrored RAID. We have copies of the data, and instead of placing both copies on one AZ, we are actually spreading it.
So there are copies of data, even though you said earlier you can do it without making copies of data. So my brain doesn't compute that, I guess.
So let me put it the other way though. We don't have to replicate. So let's take a scenario where someone is replicating, right? You still have an underlying data protection team. It could be mirrored RAID, it could be a RAID 5, RAID 6, whatever that is, right? Our protection is mirrored RAID. And we are not really creating a volume, replicating the whole thing over. So if all I need is 100 terabytes, if I'm replicating the entire volume over to another AZ, now I'm consuming 200 terabytes. But in our case, our data protection scheme is mirrored RAID. Whether I place it in a single AZ or a multiple AZ, I'm still going to require only 100 terabytes. I'm not requiring customers to provision 200 terabytes because I'm manually replicating to another AZ. So really quick in terms of scalability, to give you a perspective, like I said, we can scale up to 512 storage nodes, right, within a single cluster. And if you look at our competition, typically it's somewhere like two will be the maximum. It's either the single or the dual, right? Likewise, the active cluster capacity, we can actually go up to 4 petabytes of usable capacity. Technically, we can go up to 8, but we have introduced a soft limit. If you look at our, the leading competition, we are still like 5 times higher in terms of the cluster capacity. Volume capacity, again, we can scale up to 1 petabytes per volume, and that's about like 16 times higher compared to what you get with the hyperscalers. So I kept talking about the performance, and one of the things that someone asked was, hey, where did the 100x claim come from, right? So still waiting for the screen to refresh. Yeah, so this is based on our internal test, right? And this uses, so we essentially did a scalability test. We started off with 3 or 4 instances, and we went all the way up to 128 storage instances. And you can see that we are hitting more than 31 million IOPS on a single volume within a single cluster. So the 100x was essentially, derived from here, based on, and we can go up to 512. We only did 1/4 of it. We only used 128 instances in this case to get to the 128.
What testing methodology did you use to actually generate those numbers?
In that use case, like we had to stand up a cluster and we had to keep adding nodes. And you can see here, right? So this is just a shorter version of that. So this is a real test that we did literally like, last week, wherein we started off with 4 storage nodes.
Okay.
And then every 10 minutes, we doubled up the storage nodes. So this is keeping the SDC count the same, compute the same. All we did was start off with 4 storage nodes. After 15 minutes, we doubled up. We increased it to 8 storage nodes. And in the next 15 minutes, we doubled up again to get to 16. And you can see throughout that, we started off with 4. The numbers are not here, but essentially we started somewhere around like 250K IOPS. And, by the time we hit the 32 STS, we were over 2 million IOPS.
So I think what he may be asking is, what did you use to measure? Is this
Yeah,
an FIO or a VD bench?
Yeah, did you use an Oracle workload, or did you just use Iometer, or
This
what
is
did you
just
guys do?
this is just a standard. I mean, it's not based on any application or workload testing. Yeah.
Okay, because
Based
in
on the standard
reality,
rules.
but you are saying that this is for extremely high volume, I presume, high transactional databases, right?
Yeah.
First off, an Oracle transactional database and a MongoDB thing, you're talking about document versus, right?
Right.
You're potentially updating an entire document,
Exactly.
depending on the technology, versus one 4K or 8K block, right?
Yeah.
So again, just doing reads and writes on a block is very different than an actual TPCE workload. So that's why I'm asking.
Absolutely. And that's a great question. So, to be very honest, this test was done not using any specific workloads, but using just standard tools.
Okay.
But we have done specifically workload testing for Oracle, SQL, and MongoDB.
Okay.
And we were able to see more than 1 million IOPS with a very small configuration, right? Like 4 or 5 storage nodes. And we have papers available that's publicly available.
That was my next question. Okay,
yeah.
great.
We have publicly available papers for the past year or so.
Okay, super.
Sorry, can I have maybe a stupid question? What it means letter Z, like 3Z milliseconds?
Yeah, essentially we didn't want to provide specific numbers, so it's to,
thank you.
yeah. And we'll have once we go through all the process, we'll be able to share that.
Gotcha.
So this test talks about scaling just the storage nodes, keeping the SDC or the compute instance the same. I also talked about being able to scale compute independently, right? So that's something very unique. So you can keep the storage node as is, increase the compute, or increase the storage and keep the compute the same, right? So the next set of tests that we did was keeping the storage node the same to very minimal, like 4 or 5. And all we did was start off with a single compute instance, and we doubled up. So in here, it's scaling compute. Again, you can see that we started off with 1 SDC, the compute instance, and every 10 minutes we doubled up the compute instances. We again started somewhere around 250,000 IOPS, and we hit more than 2 million IOPS by the time we got to the 16 SDCs, right? So that's the flexibility of the product, though. Quite often what you would see is when I'm scaling out, I always have to add compute and storage. And this product gives the flexibility to add either storage or compute based on your application needs. And in this use case, you can also see that we are still the latency is maintained. It's under a millisecond while all the rebalance is happening. I know we had a question around business continuity and disaster recovery on, hey, can I replicate between on-prem and the cloud? So essentially, yes, we can. So this essentially talks about how you can replicate from an on-prem PowerFlex to the Apex block storage deployed either on AWS or Azure using native asynchronous replication. And we also have the Snap Mobility feature that is available. You can back it up to an Amazon S3. Additionally, you can replicate across regions as well. So you can create a cluster in, let's say, Amazon East and another cluster in Amazon West, and you should be able to use the same set of features. We don't charge anything additional for using the these product features. It's all built into the product.
Can we ask a question, or are you stressing for time?
No, that's fine. Sure, go ahead.
So this is obviously replication of the data. Are you providing solutions for orchestration of testing and recovery of those processes as well?
Absolutely, absolutely. And that will be discussed in the next slide. So, we'll be talking about Apex Navigator, which will essentially handle, and we'll get to that in a minute. So
Sure.
we are offering a feature wherein you don't have to do the entire replication, but take a point-in-time snapshot and just replicate it for test and dev type of use cases. We offer that feature as well.
Okay.
Yeah. Very quickly, so we talked about elevating our customers' experience by helping them lower the TCO. To be in all honesty, right? So we are using the underlying AWS infrastructure. How are we able to get to this cost savings? We are using thin provisioning, right? So this analysis was assuming 4-to-1 thin provisioning, and we had a third party come in and do an analysis of what is the savings, potential savings. And this assumes 4-to-1 thin savings along with snapshot savings as well. So that is how we derived at the cost savings for both AWS and Azure. And finally, we talked a lot about providing consistent experience across on-prem cloud, right? So along the same notes, and I'm just waiting for a second for the screen to refresh. Okay, there you go. There seems to be a little bit of a lag. Okay, so we talked about how we took the PowerFlex IP, took it to the public cloud. It's Apex block storage, right? We are using the exact same IP. We have validated with AWS Outposts, and we have validated in 2 different configurations. One, taking the software and using Amazon storage and compute, and getting all these benefits that we talked about in the public cloud, right? So that we call as a virtual setup. So we are using Amazon storage and compute in that scenario. The second one is what we call as a physical or adjacent setup, wherein we are taking a PowerFlex storage appliance and we are connecting to the Amazon compute. So we are using the PowerFlex storage nodes, the Dell PowerEdge servers.
I'm trying to understand a scenario where you would do on-premise compute going to public cloud storage. I understand the on-premise compute connected to on-premise storage with a AWS control plane. That makes sense to me. I'm just trying to understand the first scenario that you described.
The virtual one, you mean?
Yeah, what the use case would be for that. Because if you decided to go on-prem with the compute, wouldn't you just connect it to on-prem storage?
So I just have to clarify something here, though. So when I talked about the virtual, we are taking the Apex block storage software, and we are essentially using the EC2 instances and attaching the GP2 volumes, right? And deploying the Apex block storage software on the EC2 instances. So we are using AWS storage and compute. All we are taking is the storage software, the Apex block storage software. Very similar to the public cloud setup, but with Outposts. And we are extending all
so the compute and the storage.
Exactly.
Okay,
exactly.
That clarifies massively, because it made it sound like you had on-premise compute connected to just the way you said it was all.
Okay, I'm sorry if that came across that way.
And I'm trying to think, why on earth would you do that? But thank you so much. That
right.
helps.
So the virtual one is deploying Apex block storage software on AWS storage and compute. The physical or the adjacent one is taking the PowerFlex storage appliance, right, which is based on the Dell PowerEdge servers, and connecting to the AWS compute.
So I think just maybe adding the word software onto that chart that
Okay.
what doesn't want to show up on the screen for you, maybe would help.
So on the
Because it
scale,
makes it look like it's actual storage in the cloud, which was odd.
so you've been out since 2022. Scale.io was well known. You know, when Dell took over EMC, Scale.io had a limited number of installs because it went into very, very large environments. And we had several of our customers that had Scale.io in there, and we're very happy with it. So I'll tell the rest of the crew that kind of stuff there. But it was only very, very large environments. Is that true for what's going on here in the cloud? How big are the deployments that you're seeing now? An average install kind of stuff if somebody was flipping the
Got it.
to
Got it.
Apex Cloud.
Right. So with the cloud side of things, like I said, I mean, someone can start with a minimum of 10 terabytes usable. I
10
mean,
terabytes.
10 terabytes usable is the smallest configuration, but to be very honest, right? I mean, we get more efficient as you add more storage nodes.
Right. That's why it was very large.
Right.
So where are you where are these guys coming in at?
So we are roughly looking at, and we have two type of customer base. Like there are a few customers who are deploying petabytes in the public cloud, right? So we have that set of customers. We also have customers that are looking to start their cloud journey and they want to have like somewhere around 50 terabytes in the public cloud. And as they get used to it and as they are comfortable moving some of their workloads to the cloud, then they want to expand. They like the future, being able to future proof, and they are starting somewhere around 50. So we have both type of customers at this point of time.
Are you priced then for scale? So if I'm coming in at 10 terabytes, what am I paying versus if I'm coming in at a petabyte, what am I paying?
I mean, we are tiered pricing. So of course, like, you'll pay lesser if, as you scale up. But we have also switched to subscription-based pricing at this point of time. So we offer, so previously it used to be perpetual license. You pay once you have it all at all times. Now we are offering 1 year and 3 year subscription license.
It's based upon petabyte and the amount of storage.
It's based on two factors. One is the capacity. The other one is the number of SDS because
number of what?
The storage nodes.
Storage nodes, okay.
Because, I can actually deliver much higher performance as I add more storage nodes, right? So,
okay.
So yeah, you pay for the number of storage nodes and the capacity.
So if you look at a bell curve, what's the sweet spot for your customers in terms of the size and capacity that they have right now?
I think roughly around like 100 terabytes, and if they scale up, I think.
Okay.
Yeah. Okay. This will be the last slide that I'll be sharing today in my session. And yeah, essentially we saw all these features of Apex block storage. Now, how do we deploy in the public cloud, right? Within 4 simple steps, we can actually use Dell Apex Navigator to set up the underlying AWS infrastructure and deploy. So all you have to do is input the IOPS and capacity. It's going to seamlessly set up the required number of instances, set up the VPCs and things like that, and deploy the software, right? So there is another session where we will get into the details on Dell Apex Navigator. So thank you so much.